Hi kids. So I wanted to focus this video on the homework that I had assigned, the free response questions type 1 from last week. I want to just review them. I know second period was able to review them in class, but with the chaos of Friday, we weren't able to review it in period 11. So I thought I'd create a short video and kind of go over how to do these. The first problem is calculator active, and it concerns removing sand from Sandy Point Beach at a rate modeled by R and pumping sand onto the beach at a rate modeled by S. Both R and S have cubic yards per hour. This is important in terms of like how we respond. It actually also identifies that these are two rate problems, which is really the derivative of somebody. And T is measured in hours from 0 to 6. And time T equals 0, the beach contains 2,500 cubic yards of sand. Oh my gosh, I did it twice. Okay, so how much sand will the tide remove from the beach during the 6-hour period? Indicate the units of measure. So that's important in terms of your response. All you have to show for part A is the integration from 0 to 6 of R of T, the removal rate. Make sure you have the dt, and then use your calculator. This would be math 9, I believe, to evaluate what this is. And so we should get 31.8159. It does say indicate the units of measure, and since we were cubic yards per hour, this is going to be yards cubed. Okay, and so this question was worth 2 points, one for the integral and one for the answer with units. Part B. Part B says write an expression for y of t. So the first thing you should write down is that whatever expression we're coming up with is called y of t. And that it's going to be the total number of cubic yards on the beach at time t. So we already start with our initial condition of 2,500 cubic yards plus our integration from time 0 to time t. Now if we were talking about how much is on the beach and then removed, we have to start with how much we're adding to the beach minus the removal rate. What's important here with the integral is to make sure that you don't use the same variable twice. This is the fundamental theorem of calculus that we talk about how if you were to substitute in, you would have to certainly have a different variable there. So don't use t in the integration symbol. This question was worth 3 points. You won for using the initial condition, 1 for the limits of integration, and then 1 for the actual remaining part of the integral. All right, part C. Find the rate at which the total amount of sand on the beach is changing at t equals 4. So what we want to do is we want to derive our equation from part B. So if we're going to take the derivative of this, we're going to have y prime of t equals, the derivative of a constant is 0, so we don't have to worry about the initial condition, but the derivative of this integral turns out to be just the inside with t plugged in. So you don't have to show this step necessarily, but you do have to show s of t minus r of t. And we see that now that we've taken the derivative, that we put that t variable back into our original equation. All right, and then so it asks for at 4 hours, so we need y prime of 4, which is equal to negative 1.9087 yards cubed per hour. This question was only worth 1 point. And so you kind of had to just get the answer, get it right, and show the right work. Okay, ooh, I'm running out of room. Let me add a page. Oh, maybe that's not how you do it. We'll just drag this one down. Okay. Oop, going haywire here. Sorry, kids, bear with me. Okay, so here's the answer to part C, and so let's talk about D. D says, for 0 to t, what is the amount of sand on the beach at a minimum? What is the minimum value? All right? So we need to know when the minimum happens and what the minimum value is. So again, we need to identify that what we're going to use is y prime of t equaling 0. When the derivative is equal to 0, then we will have a time where it reaches a max or a min. Means s of t minus r of t equals 0. We need to really figure out on our calculators where s of t equals r of t. And that's going to happen at t equals 5.117865.3. We want to write all these digits out because we want our final answer to be pretty accurate. We can truncate or round in the final step, but when we're plugging it back in, we need to double check. So this is where we're going to do EVT. It's going to happen, the minimum is going to be at this point or when t equals 0 or 6. And so we need to show consideration of all of those points. So we've got our times over here. Sorry for the ugly lines. 5.117865 and 6. We know at 0 time that we have 2,500 yards of sand. We need to put this into our calculator into the formula up top. So what you're going to integrate is 2,500 plus 0 to your time here, 5.117865 of, what do we have here, s of t minus r of t dt. And that's going to result in 2492.3694. So that's smaller than 2,500. And then you're going to do the same exact thing, but on your calculator for 0 to 6. And so you're going to change the upper bound from 5.11 to 6, and you should get 2493.27667. All right, so now we have our answer. Clearly, the minimum is happening on this interval at our 5.1176. You have to show consideration though, and that's one of the points in this function. You have to show this consideration, and then your answer. And so I would write at t equals 5.1179 hours, the amount of sand is at a minimum of, and then use the result you have from your chart, 2,492.3694 yards cubed. And you don't actually have to give the unit to measure because it doesn't ask for it, but I'm just feeling a little extra today. And so there's your third point. What I would like you to do is to score your free response based on this response and submit it via the Google form link. All right.